from these backs and sides,
Yeah.
there's actually quite a lot of other things you can do with the vacuum press, isn't there?
There are. I mean, the vacuum pump itself, and using vacuum technology for this type of thing, all it's really doing is it's enabling you to apply pressure between either layers of material, or between one material and another, or between two objects that you're just trying to bond. A good example of that is when you're bonding a bridge onto a soundboard.
Yeah, so this is always a tricky job. You need a long reach clamp to go in there and reach. I can't even reach with my hand.
Yeah.
To reach over and clamp it.
And
so
they always
a tricky shape inside.
Yeah, and also the clamps tend to be quite big and heavy,
Yeah.
and soundboards tend to be quite light and soft.
I've seen a few get damaged during that job.
Yeah.
As you put the clamps in and out of the soundboard, you can damage the soundboard.
Yeah.
So this is one of the things I've always wanted to get hold of.
Yeah.
Is a vacuum press to glue the bridge on.
Yeah.
So you'd obviously have to locate it and pin it as normal.
Yeah.
And then you've got some holes on the inside. Or
Yeah, what I know,
not drill all the way through.
You could, it depends how thick your soundboard is. And if you can drill like a 1 mil deep hole in your soundboard such that you can get it registered with a very short pin, then fine. I tend to just drill through, and then I'll put a bit of tape on the underside of the hole.
And what sort of tape would that be?
It can be anything, literally
masking
anything. Masking tape, parcel tape, anything you like. All it needs to be is airtight. So you're just sort of covering, and if you can spread that along under the underside of the bridge reinforcement, all the better. With a steel string guitar, it's less of an issue because you tend to have another layer of material under this part of the soundboard anyway as a reinforcement.
Yeah,
on the nylon strung guitar that I made, that isn't there. So all you've got is the thickness of soundboard. So that's actually a lot more porous.
Most guitars have a bridge plate.
Yes,
So
certainly steel string. So all you need to do is just need to seal off the underside of the holes. Yeah. At which point you can then glue up your bridge, put it in place. I mean, do you want to? Can I suck that down on there?
Of course, with a bridge, it tends to have a twisting motion. You might see this on old guitars where the bridge is coming up at the back. So when you're gluing it, if you can apply even pressure along the whole bridge, you get a much better solid joint. It's much less likely to come loose.
Yeah. Yeah.
As opposed to just having 2 or 3 long reach clamps with 2 or 3 pressure points.
Yeah.
So yeah, we'll just do a little demo on there, shall we?
Yeah. Okay. Fine. So basically, all we've got here is it's just a sheet of solid laminate, but it can be anything that's airtight. I mean, acrylic would work pretty well as well. And that's just been machined with an aperture in it. You've got a vacuum tube connected on either end.
People use even MDF for that.
Well, you can use MDF. I'd say if you can use MDF, lacquer it.
Seal it, yeah.
Because MDF is very, very porous.
Right, so it needs sealing.
Anything
porous needs sealing.
Yeah, on my vacuum bed on my CNC router, I can put a sheet of 25mm MDF, turn on the vacuum table, and suck something else down on top of the 25mm MDF. You've got so much airflow going through even an inch. So yeah, it's phenomenal to watch. Wow. So this is a completely solid material, and all I've done is I just put a bit of latex on the side.
How strong is that?
You've probably got 800mm elongation on this before, or maybe more than that before it breaks. So in actual fact, all you want the membrane on this type of device to do is just to be very stretchy. It doesn't need to be especially strong, it just needs to be very stretchy.
And what was it called again?
That's latex.
Latex.
Yeah.
I've heard of neoprene being used for this. Is that similar?
Again, any stretchy, airtight material will do. And I've just used exactly the same on the bottom just to create a seal.
To create the seal.
Yeah. So what you do, position your bridge, glue it, line up with your registration holes in your soundboard, put your little metal pins through so it's held in correct position. Put your bridge clamp over the top, turn the pump on, and then you open the vacuum connection. There you go, bang.
Wow,
yep.
Look at that. And so, if I was doing this normally, we'd use white wood glue because the bridge is one of those parts that you might need to remove at a later date. We want it to be not too difficult to remove, so we use ordinary white PVA glue in here, that's what I recommend. So, put the glue on, leave it in the vacuum clamp for about 20 minutes, and then that glue will have dried enough to take this clamp off, clean out any excess, and then we would put the clamp back on until the glue's properly dried, how long would you recommend to leave it on for?
I'd probably leave this on for several hours. If you can leave it overnight, if it makes no difference to you, then leave it overnight. It is one of those bits that you want to make sure is really properly bonded.
Brilliant. And the main advantage to this, like I say, is it's perfect even pressure over the whole bridge.
Yeah.
So you're going to get a much stronger glue joint.
Yeah.
So that's the bridge. What else have you got here?
Okay, what else? So this is actually a little jig that I use for cutting the strips off. And there's a technique I use for that, but let me show you how we laminate them first. This is basically a little mould. Again, it's got this non-stick PTFE glass cloth around it, and then we've got the layers of, just to make it very simple, black, white, black, white, black lamination. And these have been cut such that they kind of all end up square once they're stretched around the mould. So we glue these up. Now I just use PVA for this, or tight bond for this. That's perfectly fine. Then what I tend to do is, once they're glued up, I'll just tape them at the back, get another bit of tape, and you'll see the reason for this in a moment. There's a little dip in the mould there, and what that does is when the layers come round and the tape over it, I'll probably put another bit of tape over there as well, a little bit further and a little bit tighter. What that does, it sucks into there. It's actually pulling the material around the mould as well. So it's just a way of making sure it's pulled really nice and tight around the mould. Okay. And then I've got so many little offcuts of polyurethane. I've just made up some little bags specifically for this.
Can be just cut to any size you want.
Normally this material comes to us on a roll, it's a completely seamless tube, so we can cut off whatever lengths. And probably the most useful width for guitar making is 800mm, so 800mm by whatever length. But I also have a welder, an RF welder, which I can use to weld up bags from offcuts. So anything for this type of job.
I suppose you could do a DIY.
You can just tape it. You'll see on the latex bag that we can use on the soundboard in a minute, it's actually just taped.
You can tape it.
Just tape the edge. Yeah. So we glue this in the right place, stick it in the bag, and again we've got this little bit of breather fabric in there. Let me put it on top so we can see what's happening with that little notch. Yeah. A small sealing strip. Connect that up and suck the air out.
And now the magic happens.
And now the magic happens. Now you see where that tape has now been sucked into that. So it's pulling the material around the mould as well.
That's clever.
Yeah.
So then we would set that aside to dry.
Just leave that to the side. Yeah.
And then tell us how we would cut strips off.
Right, Blue Peter fashion.
Grab you a saw.
Yeah, absolutely. Here's one I made earlier. What you need is a saw, and I mean it can be a little offcut of soundboard or anything really. Perfect. Yeah. How are we going to do this? Actually, I'll do it there. Okay. Get a spacer. Make sure it's not going to distort your saw. That's okay. There you go. There's fine. Right. Okay. So this is glued. Right. So the first thing you do is you put it so it's a little bit proud of the surface, and on a sanding sheet you get one side nice and
make sure it's resting on the black white black.
Exactly. Yeah. So you're leaving the black white black a little bit proud of the MDF. Sand that till it's nice and smooth. Then push the MDF down. Okay. So it's now completely flush.
That's clever.
And you just start going round.
We like that.
You just go all the way around.
As long as you keep your fingers above the blade, you'll be fine.
Yeah. Right, you get the idea.
That's fantastic. Can you see that, Lewis? Can I have a little go at that?
Yeah, of course you can.
Brilliant.
It's so much more controllable than trying to clamp the block and move the saw.
Brilliant.
Great little technique. And I'd experimented with using little cutting heads in Dremels and all sorts of stuff, but that...
Yeah, I've seen it done with Dremel.
Yeah.
But that's a clever little trick. A great little tip there from Darren. Thanks for that.
It's what rubber bands are made of, effectively. And it isn't going to apply any high degree of sideways force or pulling force because of the tension in the material. All you're going to be getting is the atmospheric pressure.
So it's not going to
exerted.
twist your soundboard or anything.
Exactly.
This is what I was worried about, because in my mind I was thinking you would need to use a baseboard.
Yeah.
You know, the domed radius blocks that we use.
Yeah.
Underneath. You don't actually need the block while you're clamping the braces.
No.
Because effectively the atmosphere becomes the block at the back.
That's right.
So
You're bending the soundboard to the shape of the braces.
So the soundboard is taking the shape of the curve
Yeah.
from the braces.
Yeah.
But it doesn't. There's no twisting or anything in
No.
between, because it's pushing against a cushion of air.
Exactly.
Perfectly evenly then.
This is a relatively complicated soundboard, but and I wouldn't try to glue all of these braces on at once even necessarily.
Okay.
So what I do, glue them up and then bend the soundboard, just a little bit of tape at either end.
So you put your glue on the brace and
position it.
tape it in place to start with.
Yeah, yeah. And occasionally, depending upon the shape of the brace, I might even put
some extra ones.
just extra ones just to keep it.
So that's just to stop it from sliding.
That's exactly to keep it in position. Right.
Whilst the bag gets a grip.
So we then put it in the bag. Get the sealing strip.
This is clever, the sealing strip, isn't it?
It's just very, very simple. You can take that one off.
Take this
Yeah.
off and show. So it's the U-shaped square section and a round thing that fits in perfect. That creates a seal.
Yeah.
Very clever.
And even on this thicker latex bag, it's a little bit harder to push in, but it's not difficult. You do need to make sure it's pushed in all the way down with a latex bag, because it is thicker. But that's created a perfect seal there now. Grab one of our vacuum tubes, connect it up, open it up.
Wave our magic wand.
Now this, you can see, has just been taped with glass tape, so this isn't welded. This has literally just been folded over, and it's got sticky tape down both sides.
So it shows how versatile it is, doesn't it?
Absolutely. I mean, once you've got a vacuum pump, you'll find all sorts of different things to use it for. Now you can see there how sucked down around all the bracing on the...
Even on this, the sound hole reinforcement piece there. And how thick is that piece
That's
of wood?
0.8 mil thick.
That's 0.8 mil thick.
There's a little bit of birch ply.
That's incredible, isn't it?
So again, you can be guaranteed that the pressure that's being exerted on the glue line is completely even. So you're not squishing glue out of one side and leaving thicker glue line on the other. Completely, totally even pressure.
Look at that. We're in the future, folks. We're living in the future.
So when you look at the other side, you can see it's sucked completely.
Yeah.
So all that's happening is we've got pressure being exerted directly from one side of the bag to the other. The pressure is going that way, in effect, on anything that's in the bag. And because the pressure on the side of the braces is the same, there's nothing pushing it one way or pushing it other. And that's why we use the latex. If we use polyurethane, there'd be a danger that, because this doesn't stretch the same, that you have more loose on one side than the other, in which case when it sucks down into that void, it'll be tending to tip it and pull it. Whereas with latex, that doesn't happen.
So for accurate positioning jobs like this, you need to use latex.
Absolutely, yeah.
That's fantastic, amazing. So incredibly versatile, and there's loads of other stuff you can do with it. I'm sure you guys will think of a million other uses for it. One other thing that excites me about this is give me the ability to make 335 guitars which is basically layers of veneer, 5 or 7 layers of veneer, maple usually, laid up to make this curved shape, so that your back and your front doesn't need any bracing. The shape comes from being pressed from a mould. So that's something that I've never been able to do before. This Bagpress system would give me the ability to do that, so that's quite exciting.
Yeah. Watch this space.
Watch this space, yeah, look out for that. A new course, build your own 335. There you go. So thanks for showing us that,
My
Darren.
pleasure. It's been great.
Brilliant, yeah.
Spend some time here.
Thanks for coming and showing us all that stuff. Much appreciated. So I think we should maybe let Darren show you some of the guitars that he's made on our course.
Okay.
Let's do that.
Let's turn this off.
I'll turn that off as well.
Yeah, perfect.
I'll edit it all down so it'll look smooth.